Thank you, Santosh, for a nice introduction. In this workshop on advanced in biomedical instrumentation for quality healthcare, I would like to give a presentation on the application of the wireless network, that is wireless body area network for health monitoring. As I mentioned in the introduction, I am working as a professor in the Department of Telecommunication Engineering at TSSS ITW Mysore. In this particular talk, I am going to cover these aspects. What are wireless networks? What is the classification of wireless network, and what is wireless body area network? What are their properties, architecture, protocols used, the technology associated with the body area network, and what are their applications in health monitoring, and some of the research evidence. As you know, previously we were using the wired network. In the case of wired network, the different computing devices can be connected with the help of the wires. And when the devices are connected, when I say computing device is any device which is having the processor or controller as the processing element. The problem with the help of the wired network is that when you want to expand the network or move the network from one location to another location, the entire setup has to be changed. That's the drawback of the wired network. And in order to overcome that disadvantage, we are going to go for the wireless network. And wireless networks are basically networking of the devices by means of air, by using the radio waves or electromagnetic waves. And even it can be connected with the help of the RF waves also in the case of the line of sight communication. And how these wireless networks can be classified? The wireless network can be classified depending upon the application and signal coverage. Depending upon the range of coverage of the signal, it is classified into different type of wireless network, and each type of wireless network has its own application. Let's start with the body area network, the wireless body area network. It can cover a signal range of 5 meters, and it's mainly used in the health monitoring. Since very much associated with relevant to the topic of the workshop, I have taken the body area network for the presentation. And different types of networks have different data rates. And in the case of the body area network, we have a maximum data rate of 1 megabits per second. And in the case of the personal area network, it can go up to 10 meters. And it can support a maximum data rate of 10 megabits per second. And in the case of the wireless LAN, the maximum signal coverage area is 1 kilometer, and the maximum data rate that is supported is 100 Mbps. And if you go for the metropolitan area network, in the case of maybe within the city, metropolitan area network, it can go up to 10 kilometers, and the data rate that is supported is 100 Mbps. And then you have the wide area network. In the case of wide area network, if the network coverage area is more than 10 kilometers, we go for the wide area network, and it can support a maximum data rate of 10 Mbps. And the wide area network is basically satellite or cellular communication. Next. And in the previous figure. In the previous figure, it's indicated what are the technologies used in the different types of wireless network. So when it comes to the wireless body area network, as I mentioned in the previous figure, it can cover a maximum signal range of 5 meters. And what are the main applications of this body area network? It's mainly used for health monitoring. And these particular networks are also called as the wireless sensor network, because it's mainly used for transmitting the information from the sensor, which can be placed on the surface of the body or implanted within the body. And the informations are collected from the sensor, and the information is passed on to the hospital or the health center, wherein the monitoring of the data is done and maintaining of the database is done. The advantage of this wireless sensor network is, suppose if a particular patient, if you want to monitor the vital parameters of the patient for a long period of time, he need not have to be hospitalized. Okay? And the data can be taken from the patient with the help of the sensor, which can be placed on the surface of the body or implanted within the body, and it can be transmitted over the network. And once it is transmitted over the network, and the expert who is at the hospital will look into the parameter value, that is the data that is collected from the patient, and inference can be made. It is proper medication or the treatment to be given for that particular patient can be made. And suppose if a particular parameter is exceeding the alarm limit, then immediate attention can be made. That is the doctor along with the ambulance can approach the patient, or ambulance can approach the patient, and it can be brought to the hospital. Before he is brought to the hospital, the proper the facility for the operation or the treatment can be made at the hospital. And whenever you use when I say the sensors are placed on the surface of the body, the associated the circuitry for the sensor. The sensor basically, depending upon the parameter to be measured, we are going to use different type of sensor. It can be ECG sensor, EEG, EMG, or the glucose monitoring sensor. And whatever may be the type of sensor that is used, once you acquire the data, it cannot be transmitted as it is. Because different type of signals have different types of output, different voltage characteristics, and different frequency characteristics. In that case, it has to be conditioned. And once you condition, it cannot be transmitted as a raw signal, you need to process. And since the analog signal processing is difficult, we go for the digital signal processing. And if you want to process the signal by using the processing element, you need to convert that analog signal, that is the conditioned analog signal, into digital signal. For that, we go for the embedded processor or the microcontroller, or even the DSP processor, depending upon the type of signal that is encountered. And since if you want to incorporate all these things, whatever sensor that you are going to use, it has to be a smart sensor. Smart sensor in the sense it should have the capability to condition the signal, it has the capability to digitize the signal, and then you should have a transceiver for sending the information to the medical center, or suppose if there is any feedback that is given from the hospital to the patient, you need to be in a position to receive that. Therefore, you require a transceiver. If you want to incorporate all these things in the sensor, it has to be a compact. Suppose you have a separate device for each of these, then the size of each sensor, is going to be voluminous, and it cannot hold it for a long time. Therefore, whenever you use the sensor for these applications, body array network, it has to be compact, it has to be lightweight. If it is of higher weight, then it cannot hold it. Okay, therefore, it has to be compact, it is lightweight. And when you go for the implantable sensor, as mentioned in the previous presentation, it has to be biocompatible. It is the material that is used for the sensor has to differ with the characteristic that is inside the human body, where it is implanted. You should not have an adverse effect on the internal proceedings inside our body. Whatever mechanism that is taking place in our body, it should not be disturbed after the insertion of the sensor. Therefore, you take more precautions whenever you are using a sensor which is implanted inside the body. And what are the, apart from the biocompatibility, what are the other features to be considered when you are using the implantable sensor is that the battery life. When you want to perform this signal conditioning, the digitization and the processing, you require a battery. And the battery has to run for a longer time. Suppose if it is implanted outside the body, the battery can be replaced. Okay. But if it is implanted inside the body, so whenever the battery life goes down, not to replace the battery, again surgery has to be made. Again it's a risk for the patient and additional medical expenditure for the patient. Therefore, Whatever sensor that you are going to use for smart sensor that you are going to use for the implantable purpose has to run for a longer time, and if not, it has to make use of alternate source of the battery. That is, it can make use of the RF energy, it can be transferred from outside the body, and using the, if you transmit the RF energy from outside the body and within the body, and that can be used for the charging, so that the problem of the battery source for the smart sensor can be eliminated. And the body area network consists of a set of the mobile and compact intercommunicating sensors. Okay, when I say mobile means it has the connectivity. The sensor will have the connectivity even if it moves from one place to another place. That means if the sensor, the person is having the body sensor, it need not be a particular location. Maybe when a particular patient goes to the hospital, while taking the data from the patient, it cannot move. It has to be at a fixed location, and the data is taken from the patient with the help of the wires connected to the sensor that is placed on the body. But here, even if the patient is moving around, the data should be connected to the receiving. Therefore, the sensor should be mobile and it has to be compact. When it is compact, the size has to be reduced. And mainly in the case of smart sensor, the size of the sensor depends upon the battery. And as the battery size goes large, increases, then the size of the sensor also increases. Therefore, you need to have a compact battery so that you can reduce the size of the sensor. And these are intercommunicating sensors. That is, one sensor can communicate with the other. Each can be called as a node, and each node can communicate with the other node. Maybe mainly in the case of we have the ad hoc network, the node can communicate with each other. Or you require an intercommunicating sensor. And these devices from the surface of the body, how it communicates with the network. In order to communicate with the network, we have what is known as the intra-body communication and the extra-body communication. The intra-body communication means communication from the sensor that is placed on the surface or within the body and the gateway. Okay, it can be a PDA, personal data assisted. From that, the data can be transferred from the sensor to the PDA, and from there it can be transferred to the wider network with the help of the internet. And here the data is transferred from the sensor that is placed on the body or within the body to the base station or the access point with the help of the access point or the base station through the personal data assistant. From there it is transferred to the network with the help of the internet. So this the body area network has emerged as a promising technique that has revolutionized the way of seeking healthcare, which is often named as the e-healthcare. It is in the case of e-healthcare, the monitoring is done. The patient and the treating doctor need not be face to face. They can be at different locations. In spite of that, the doctor can treat the patient by looking into the parameter that is collected from the patient. So whenever a treatment has to be given for a patient, what we require is the condition of the patient. To know the condition of the patient, we have the different the modalities to acquire the data. It can be the physiological signal monitoring or the monitoring of the image. Okay, whatever may be the thing that is acquired from the patient and it is transmitted, maybe this will be very much useful in the case of the bigger hospital network like the Apollo. We have Narayana Hrudayalaya. The expert cannot move around to different places. It can be at one location, and from that location, from a central location, you can acquire the data, and you can look into the data, and immediately the whatever is the advice that can be passed on to the patient. It's somewhat of the improvisation of a biotelemetry. In the case of the biotelemetry, you have the gadget that is present outside the body. You have all these things are present on the surface of the body. Therefore, since you are making use of the electronics for the monitoring of the healthcare, It is called as the e-healthcare. And here, as I told earlier, instead of patient and the treating doctor face to face, they can be at remote locations, and the data can be transferred or monitored from a remote location. It can be monitored continuously. Suppose if you want to monitor the data continuously, it is not feasible for the patient to stay in the hospital for a long time. Suppose he has to be monitored for 1 day or several weeks. You don't know when the particular parameter goes above the alarm limit. In that case, until that particular situation arises, it's not advisable for the patient to stay in the hospital. In that case, he can do his daily activities, and the data can be acquired and transmitted over the network. And when you have the algorithm, when you have software running in the background, and whenever the particular parameter exceeds the alarm limit, the indication will go back to the patient also, and also to the doctor. Sometimes the patient may be negligent to know a particular parameter has exceeded a value. He will not approach the doctor, see that I have a particular problem. Suppose if it is a noticeable problem, then he will approach the doctor. Suppose if the problem is not noticeable and if it is inherent inside the body, then this face-to-face approach, it will not be useful. And in such a case, the body area network will be useful. Whenever the parameter exceeds an alarm limit, the indication will go to the doctor, and sometimes even the hospital authorities can remind the patient about the medication. Suppose if he has forgotten to take the medication, it can be the hospital authorities can inform. And another thing is the data can be stored in the database, and whenever the patient, even if you want to approach the hospital, maybe in near future, the data can be taken and it can be looked into it, and suitable solution can be given. Mainly there are two types of network topologies that is used. One is the infrastructure-based wireless communication and the infrastructureless-based wireless communication. When you say the infrastructure-based wireless communication, so you will be having a computing device, as I told, it can be your laptop or a computer, and that will be having what is known as the network interface card. That's the basic thing that is to be used for the wireless communication. Along with that, you will be having what is known as the access point. And the advantage of the access point is if you want to communicate the wireless network with the wired network. See how the wired network is interconnected with the help of the Ethernet cable. And if you want the wireless network to be connected to the wired network devices are connected with the help of Ethernet cable, and different wireless devices, it can be connected with the help of what is known as the antenna that is present in the access point. And with the antenna, it can cover a range of 500 meters, and it can go up to 250. The users can be connected to a particular access point, and once the data comes to the access point, it can be routed to the wired infrastructure by using the Ethernet cable. And similarly, that is in the case of interconnecting the wired network with the external network with the use of the wireless infrastructure. But if you're not using the wired infrastructure, in that case, from the access point, it goes to the network. That is in the case of the infrastructure-based wireless communication. And sometimes, suppose if the network has to be established momentarily, in that case, we go for the infrastructure-based wireless communication. It's also, there are two types mainly. One is the peer-to-peer or ad hoc network. The other is the multi-hop network. And the difference between the infrastructure-less and the infrastructure-based the wireless communication is that in the case of the infrastructure-less based wireless communication, you will not be having the access point. Therefore, in that case, in the case of infrastructure-based wireless communication, the different devices, they are interconnected with the help of the access point. That is, data from one node to another node. It cannot go directly. From node 1, it goes to the access point. From access point, it goes to the different nodes. And whereas in the case of the infrastructure-less based wireless communication or peer-to-peer or ad hoc network, the different devices can be interconnected directly without the access point. And whenever you will have the access point in the case of infrastructure-based wireless communication, the data, even though the two nodes are nearby, they cannot intercommunicate. The data has to pass through the access point. Therefore, the access point as the base station acts as the controlling authority. That's what an infrastructure-based wireless network, all the communication has to pass through the access point or the base station, even though they are in the same range. So radio range means different networks have the different range. In the case of the broad area network, 5 meters is the radio range for that particular network. And in the case of personal area network, it is the 10 meters. Even though they are in the same range, they cannot intercommunicate. It has to pass through the access point of the base station. Next. This is what the figure indicating the two types of wireless network. The first one is the infrastructure-less wireless network or the ad hoc network, and the second one is the infrastructure-based. Here you have the base station. Through the base station only the different networks are connected. And how does the one network is connected to the other network? So we have the broad area network. The next is we have the personal area network. Now the broad area network is connected to the other network. It is connected through what is known as the gateway. And depending upon the neighboring network, we are going to use different types of gateways. Suppose we are interacting, if you are communicating, if you are establishing communication between the broad area network and the personal area network, in that case, even if you use the personal data assistant, that is sufficient for communicating the data from the broad area network to the personal area network. But if you want to extend to a wide area network or the metropolitan area network, in that case you require what is known as the mobile phone with the GPRS facility for the transferring the data from the broad area network to the wide area network or the metropolitan area network. In the first case, you are transferring data from the broad area network to the local area network. There you are using the PD as the gateway. And in the second case, you are transferring the data from the broad area network to the wide area network, or you are using the mobile phone with the GPRS facility, or even you can say the internet. The internet is used for transferring the data from the broad area network to the wide area network. Therefore, the internet has the gateway for transferring the data from one network to the other. So, what are the requirements to be satisfied for the broad area network? One is the ultra wideband signaling scheme. Therefore, you need to have a wide range of bandwidth. Why you need to have wide range of bandwidth? The parameters associated with the broad area network have different signal characteristics. Therefore, you need to have the scheme should support the wide band, and the frequency range that is used for the broad area network has to be below 6 GHz. And whenever you go for a higher frequency, the amount of electromagnetic energy that is exposed to the human body increases. Therefore, we have what is known as specific absorption rate, SCR, and that indicates the amount of energy that is exposed to the human body whenever he comes across with electromagnetic radiation. And it has to be within the alarm limit for the frequency has to be below 6 GHz, and support of the heterogeneous multi-hop link. See, heterogeneous link means we have different sensors, we have different signal characteristics. They might have different frequency range, different data rate, different bandwidth. In that case, it has to support the heterogeneous link. And multi-hop means whenever you want to transfer the data from one node to the receiver, when the distance between the node to the receiver is large, in that case, the signal has to be of higher power. Not to reduce whenever you want to transmit the signal with higher power, even the battery power, the battery has to be of higher capacity. And in order to prevent that, what we do is we are going to use what is known as the multi-hop communication. Therefore, the information is passed on from the one node to the receiver with the help of the intermediate node. And then you have the specific absorption rate. That's what I told. Since in the case of the body array network, the sensor, the human body is exposed to the electromagnetic radiation. The amount of energy that is exposed to the human body due to the electromagnetic wave has to be well within the absorption rate. And the specific absorption rate tells you the amount of energy that is absorbed per second per kg of the human weight. And this particular example tells you how the data is transferred from the body array network to the hospital. Here the patient, the data is taken from the patient, and maybe you can have a technician to place the sensors on the body, and the data will go to the health server, and the health server in turn transfer the data to the hospital server. It is the health server can be a local server, and the data can be transferred from the body to the local server. From there, it is transferred to the hospital server, and once it is passed out to the hospital server and the processing is done, and that can be referred to a doctor, and the feedback can be given to the patient regarding any medication or whether he has to approach the doctor, or any such suggestion or any feedback to be given from the hospital side. It can be passed on to the patient through the network. And what are the properties that has to be fulfilled in the case of the wireless body array network? And in the case of the wireless body network, the electromagnetic pollution should be low. That is, the exposure of the human body to the electromagnetic radiation has to be as small as possible. And here, each node, that is sensor node, transmits at extremely low power. Therefore, since it is transmits at extremely low power, the transmission power should be below the spurious level of the electronic devices. As I told already, it should have a suitable technology for a non-invasive the body array network is the ultra wide band. And here, instead of sending the data continuously, what we do is the data is sent in terms of nanosecond pulses. And the nanosecond pulses, the data is sent, and this allows the ultra wideband information to share the spectrum with the existing the narrowband broadcasters without causing the interference in the network. Yeah, that's what I told. In the case of instead of using the carrier signal, if you want to send the data continuously, make use of the carrier signal, and depending upon the signal to be transmitted, that will be used as a baseband signal, and you are going to vary the characteristics of the carrier signal that is sent. Instead of that, in the case of ultra wideband, you are going to send the data in terms of the extremely short, that is maybe of nanosecond pulses, in order to enable very high bandwidth to be effectively utilized. And in the case of the body array network, if you are using the implantable sensor, it is difficult to frequently change the batteries in the sensor since they are implanted inside the body. Therefore, the battery has to run for longer. And the multi-hop communication, that's what I told. Whenever you want to transmit the data from one node to the receiver, instead of transmitting the data directly, you can transmit through the intermediate nodes. That's what we call as multi-hop communication. That is transmission from one node to another node, it's called as hopping. It's jumping. And the optimum node density. The optimum node density means the number of active nodes in a network. For a particular area, what are the number of active nodes in a network? It is called as node density. You need to have the node density has to be as optimum as possible so that you can transmit the data at the higher data rate. And the effective and efficient and cost-effective the body network solution is whenever you want to have these gadgets placed on the surface of the body, So whatever you use it for the monitoring of the data from a patient, it has to be cost effective. If it is so much costly, then you will not go for the border network. Instead, you directly approach the hospital. Therefore, whatever you do, it has to be cost effective and efficient. Because why it is efficient? It is related to the life of the patient. Therefore, the acquisition of the data and transmission of the data has to be as efficient as possible. It should be comparable to the or similarly efficient to the face-to-face diagnosis in the hospital. And the node communication in this case will be usually simplex in nature. That is one-way communication. And that's what I told earlier. The devices used are quite heterogeneous and have different demands and may require different resources to network in terms of the data rate, the power consumption, and the reliability. And the security mechanism is responsible for providing security services on specified biomedical data when requested to by the application. That is, whenever you send the data over the network, the data that is sent over the network, it should not be accessible by the unknown person or non-authentic person, because the data are confidential. And suppose if hacking is done, then the health information about a particular subject will be known to an unknown person or unwanted person. In order to prevent that, you need to provide the security for the data to be transmitted. It is not only cost effective and efficient, it should also be secured, and for that we go for the data encryption. That is, we go for the cryptography techniques. And as you know, in the case of the cryptography technique, the data is encrypted. That is, the data is converted to form which is not possible for the unauthorized person to decode the data. And as you know, those who know about the cryptography will be using what is known as the secret key and the private key. And only the secret key will be used for know the time of transmission of the data, and the private key, those having that key, they are authentic, and only when you authenticate, the data can be retrieved. Before transmitting the data by the person, a particular person to the hospital, the registration has to be made. The registration has to be made, and the hospital authority will be having a dedicated line for the communication of the data from the subject to the particular server. So that, and even in that, only when it is authenticated, the data will be accessible by the hospital service. The patient will authenticate the hospital authorities for using the data, and as a result, he can access the data, and an unknown person cannot access the data because the data is encrypted. And it has to be provide the data integrity. When you come to the architecture, network architecture in the case of the wireless body area network, you have the three-tier network that is generally used in the case of the body area network. And in the case of the tier 1, you have the sensor with the signal conditioning, A to D conversion microcontroller and the transceiver. As I told earlier, the sensor will be placed on the surface of the body, and the data is sensor output will be a different form, and that is conditioned by using the signal conditioner. And sometimes the processing has to be done. And instead of analog signal processing, we go for the digital signal processing. Therefore, it is converted to digital form by using the analog to digital converter. And in the digital data that is obtained, it is processed by using the controller. And even when you use the processing, the advantage of sending the processing data is the size of the data is going to be reduced. Only the required data is transmitted over the network. Therefore, the network resources can be utilized properly when you are transmitting the processed data instead of sending the raw data. Therefore, in order to eliminate the transmission of the raw data, the processing is done by using the embedded processor, and then it is transferred using the transceiver. You have the antenna, that is help of that it is transmitted from tier 1 to the tier 2. And the tier 2 consists of it can consist of a personal server or access point or a mobile phone with the GPS facility. and if the type of network, if that is a personal area network, then we have with the PD as the gateway. From that it is transferred from tier 1 to tier 2, and between tier 2 to tier 3, you have the internet is used for the transferring the data from tier 2 to tier 3. And the medical server is present in the tier 3. That's what I told you. In the case of tier 1, we'll be having the sensor nodes. We have the signal conditionings, maybe some of sensors, simple signal conditioning, therefore then we have the ADC, microcontroller, and the transfer. These are part of the tier 1 in the case of the WBAN architecture. Then tier 2 devices can be personal server, it can be wireless LAN or cellular phone with the GPS facility. And how does the communication that takes place between the body area network and the next tier? It can be through the communication technology such as the Zigbee or the Bluetooth. And in the case of the tier 2, it's not only receive the data from tier 1 and send it to the tier 3. Even if you want, you can provide the graphical or the audio interface to the user. If you want to know what is the present status of the data, that information can be passed on to the patient while it is transmitted to the hospital by using what is known as the audio interface or the graphical interface. And that is possible in the case of the tier 2. And as I told earlier, the medical server resides at the tier 3. And the information from tier 2 to tier 3 happens with the help of the internet. And the tier 3, and from the tier 3, the different user can access the data. That is medical that server. It can be accessed by the hospital authorities or the doctor who is in charge of that particular work. Several hundreds or thousands of users can access the medical server in order to process on that particular data. And what are the issues to be considered when you are designing the wireless body area network? You should know about the node types. What are the nodes that is used in that particular body area network? The node types. And the node type means depending upon what type of parameter you want to measure, you will be using the different types of nodes. That is different type of sensors. It can be health monitoring sensors such as ECG, EGFG, or it can be environmental sensors. Maybe when you are treating the asthma patient, you should know the allergic conditions, the conditions which causes the allergy in the atmosphere. That is done with the help of the environmental sensor. And suppose if the patient is under the rehabilitation, it can be affected with the stroke, or it can be affected with the undergone some surgery. Then if it is under rehabilitation, we need to monitor the position of the person or the motion of the particular person with the help of the various sensors. We will be placing the motion and position sensors, and from that the information is passed on to the hospital server. Therefore, should have the knowledge of what type of sensors you are using that particular network, and the sampling rate for the sensor. And the sampling rate depends upon the signal character, what is the signal frequency, the sampling rate is going to change. And most of the physiological parameters will go up to 30 Hz, therefore a sampling frequency of 100 Hz is sufficient. Even if any sampling frequency more than 60 Hz is sufficient, we will have safer side, that is 100 Hz as the sampling frequency that is employed in the case of the WBAN. And the operating power. As in the sensors are smart sensors, they are battery operated. The battery resource is a major criteria, and if you cannot afford with the battery that is allowed in the sensor, then you can go for the self-powered sensor. Self-powered sensor means you are making up the RF energy, the help of antenna that is upward, and that is converted into the DC, and with proper conditioning that is used by the sensor. And the size and weight of the sensor. And since the sensor is placed on the body, the person, if you want to hold it for a longer time, both the size and weight of the sensor is a point. If it is of higher size or weight, that if it is of higher size means you cannot place the required sensors on the body. And if it is of higher weight, then you cannot hold it for a longer time. Therefore, the size and weight of the sensor is a major factor that is to be looked into while selecting the sensor for a particular application. And the sensor node identification and association. See, this different sensor that is placed in the body network, it is referred as a sensor node, and it will be having a unique ID. And it will be having a unique ID, and that is identified with the help of that particular ID. Since the students will be identified by different user number, so the node will be identified by different ID. And if at all it has to be accessed in the network, that ID will be used, because even the receiving end, if you want to know it is the data from which particular sensor, it will be having the ID associated, that can be used as a header, and the ID will be used as a header, and by looking to the header you can know what type of signal that is. And the sensor calibration, whenever you have a sensor, it has to be calibrated, because different sensors will have different characteristics. Therefore, sensor calibration is done when it is used in the beginning, and whenever any monitoring session is done. Suppose if you monitor the signal on different sessions, in each session the calibration has to be made, and only when the calibration is made, the data inference can be properly made. The processing, that is the intelligent on-sensor signal processing. The intelligent on-sensor signal processing means, instead of having only the conditioner, signal conditioner associated with the sensor, even if the sensor is having the processing capability also, then it is more compact. The sensor node will be more compact, and different sensor nodes, more amount of sensor nodes can be incorporated. If the sensor that is used, the sensor node that is used is intelligent. Intelligent means it is having the processing capability. And as I told, instead of sending the raw data, if you are having transmitting the processor data, the amount of data that is sent over the network can be minimized, and as a result, even the time for the transmission is reduced, and when you reduce the time of transmission, you are reducing the power. You are going to reduce the power that is required for transmission of the data. And social issues means the privacy for the patient. Suppose if a particular patient goes to the hospital for the treatment, and whatever the information is there, it will be between the doctor and the patient. But when it is transmitted over the network, can we provide the privacy for that particular measurement, and whether it is providing the security and legal aspects. Suppose some hacking is done, then how to encounter that? Those are the legal aspects. And the protocols, if you want to control the communication, you need to have certain standard, and those standards are nothing but the protocol, that is protocol that is associated with the network. And the protocols of the body network can be divided into two types. One is the intra-body communication and extra-body communication. The intra-body communication means communication of the data from the sensor and the gateway, which can be also referred as a sink. And the intra-body communication controls the information from the sensor at the sink. And as I told in one of the previous figure, you have the personal data assistant that acts as the gateway. Okay, that acts as the gateway, and that is used for the intra-body communication. That is from the body to the personal area network. And the extra-body communication controls information from that gateway to the external network. Okay, therefore the extra-body communication, you can go for the internet for transmission of the data from the sink to the external network. External network can be the destination. If it is a medical server, to the internet it can be transferred. And when you come to the network architecture, for the proper handling of the network architecture, you have network architecture is basically divided into 7 layers as per the OSI model. You have heard of the OSI model, the Open System Interconnect, and that model you have the network architecture is divided to 7 layers. That is physical layer, data link layer, you have network layer, then transportation layer, presentation layer, application layer, and the session layer. Okay, we have 7 layers, and the advantage of having the layered structure of the network is, suppose if you want any network handling, you need to have the programmer, and the programmer can be specialized in a particular layer, and he can write the software for that particular layer, handling that particular layer, and also if you want to modify the network, that is update the layer, the updating of the layer can be done independently. And whenever updating is done, it will not have little or no impact on the adjacent layer. So the updating can be done, handling of the data, handling of the layer can be easily done, and different layers will have different protocols. And the development of the protocols and updating of the protocols can be easily done when you have the layered structure. And in the case of the body array network, the 3 layers are associated. One is physical layer, the data link layer, and the network layer. Let's see about the protocol that is associated with these layers. So when you come to the physical layer is the lowermost layer that connects the data on the body to the and in the case of the inductive coupling, it achieves the best power when you are having when you want to have a continuous monitoring of the data. Then in that case we go for the inductive coupling. But the problem in the case of inductive coupling is it will not support the higher data rate. Suppose if higher data is required for transmission of data, that is not possible. And also when you want to have the communication from inside the body. Communication from inside the body means if you have implantable sensor, then if you want to transmit the data, then inductive coupling cannot be used. The next possible the option is the RF communication. In the case of RF communication, see, compared to inductive coupling, the RF communication it can provide a higher bandwidth. Therefore, if you want to have a higher bandwidth, in that case we go for the RF communication. And then we have the antenna. That is, if you want to transmit the data, you require the antenna. And the size of the antenna is a major factor, because when you want to have a compact thing, the size of the antenna is a major factor. Therefore, the non-resonant antenna is a better choice in terms of the size of the antenna, and the alternate for that is the patch antenna. Then you have the different modulation techniques. One such modulation technique is the direct sequence spectrum, and you have a different version. And the different version will have different frequency bands. And what is the technology that is associated is the Bluetooth, Wi-Fi, and Zigbee. And the Bluetooth is the short range wireless standard for the short range communication, and that is developed by the special wireless, the Bluetooth special interest group. And Zigbee is also another wireless standard that is used for the short range communication. And the alternative wireless technology is the ultra wideband or the USB. Let's come to the medical applications for the wireless body network. It can be used for handling the cardiovascular diseases, and the sensors can be installed on the body, and the information from the sensor, maybe you can place the ECG sensor. From that, by using the sensor, you can get the information about the heart rate, whether it is bradycardia or tachycardia, that is the fast heart or slow heart, or if it is having the arrhythmia. Those information can be passed, can be obtained with help of sensors placed in the body. And the cancer detection. See, by measuring the nitric acid, it's a measure of whether it is cancer or non-cancerous cell, by measuring the amount of nitric acid that is emitted by the cell, you can differentiate between the cancerous cell and non-cancerous cell, and the cell identification becomes easier by measuring the amount of nitric acid associated with the cell. And it can be the asthma, depression, and the elderly people. The glucose level monitor. You can monitor, you can implant the biosensors in the patient to not measure the glucose level, and whenever the glucose level goes about the alarm level, the insulin can be injected. That's what the sensor node will be having what is known as sensor and actuator. Okay, the node will be having both sensor and actuator. For measuring the parameter, you require a sensor, and for performing any control action, you require an actuator. Therefore, you not inject the insulin, you require an actuator. It can be the treating asthma. By using the environmental sensor, you can sense the allergic agents present in the air, and it can be reported to even the patient and also to the doctor. And in terms of the medical accident, the information will be passed on to the hospital, and by knowing the location of the sensor, the location of the particular subject can be easily identified. And that is, epileptic seizure can be detected and proper care can be taken. And this one unit that is used to detect the abnormal brain activity that usually occurs before the epileptic seizure. But the problem is the development of suitable algorithm for that. Okay? And that's one of the research issues which can be tackled on. That's hip card system. It's developed for the patients who are undergoing the hip surgery. Here by using the position sensor, the status of the patient can be obtained, and by obtaining the information from that sensor, we can know what is the rehabilitation, whether the patient is properly rehabilitated or not. That is, whether he is undergoing proper recovery or not. That information can be obtained from the information from the sensor. This particular application is mainly used in the case of the emergency care and the stroke patient rehabilitation. This is what? With the help of this, of the different sensors, send the data to the service provider in order to know the health status of that particular patient. This is what? The e-watch, that is a wearable watch with the associated sensor that is used for sensing, notification, and the computing control. And it's a shirt that having the required sensor that is implanted on the body, and with help of that, the wearing of the sensor is easier because the sensor will place on the body. He just has to wear the shirt, and the information will pass on to the medical server through the method that I have explained earlier, which gives the health status. And what are the research revenues? As I told, the major factor in the case of audio network is the miniaturization of the sensor. Therefore, miniaturize the sensor in order to reduce the size and weight is one of the research revenues. And the design of the adaptive wireless protocol to accommodate the critical, non-critical data with low latency and information fast permanent. That is, whenever the data is transmitted, there are certain critical data and non-critical data. And your network should identify which is the critical data and which is non-critical data. And the priority has to be given to the transmission of the critical data by sidelining or giving the next priority to the non-critical data. That is development of algorithm. That's one of the research avenues. And providing the security for the data to be transmitted. That is, which for the confidentiality of the data to be transmitted, you can work on the providing security by using the proper cryptographic technique. And The development of sensor data processing algorithm that can reduce the amount of the radio transmission and reduce the battery power. See, reduce the amount of radio transmission means one is the exposure of the patient to the electromagnetic energy can be reduced, and also you can reduce the duration of transmission, hence the battery power can be saved. And you can work on the biocompatibility, because whenever you use the sensor for implantable purpose, it has to cope up with the inside body activity. Therefore, it is biocompatible, and that is optimness, that is transmission of data from continuous transmission of data from one network to the another, optimization of network resource, then preventive health care, and the computational economic perspective. Computational economic perspective means the computation of the data has to be optimized, and also the economic. So I told the economy is also a major factor in the case of body network. It has to be affordable by the user. Therefore, I want to look into that. And these are some of the research avenues that you can look into if you want to do some work in the area of the wireless network, wireless body network. Any inquiries? Okay, there are no queries.
The session is open for the queries. Please, if you have any queries.
Or you can interact with now or even in the deliberative session. Okay, thank you for the patient here.
I request Dr. Kumar to hand over the token of